Then quadrant 3. So this big angle is 7 pi over 6. What is the related acute angle?
Pi over 6.
Yes, perfect. Pi over 6. So what does that mean? CAST, sine is negative in quadrant 3. Sine of 7 pi over 6 is the exact same thing as sine of pi over 6, except in quadrant 3 it's negative.
Right.
That sine of 30, I think that's 1 over 2 from the special triangles. Let's look at C. In which quadrant is this in? Well, this one is a little bit tricky. This is gone over 2 pi's, yeah? This has made multiple rotations. So what you could do to this is you can, what is this? This is 2.25 pi. I'm just gonna add 4 pi to this. So I get a positive angle plus 4, and we're allowed to add multiples of 2 pi, okay? Or you can even add 2 pi to it, actually. Let's add 2 pi to it. So this will give me cosine of negative pi over 4. Okay?
Okay.
Now, in which quadrant is that?
Wouldn't that be in quadrant 4 or quadrant 3?
Yeah, well, try again. It's not in quadrant 3. Negative pi over 4. Okay, that means negative 45. Okay.
Yeah.
Whenever an angle is negative, instead of going counterclockwise like this, you want to go clockwise. Okay, you want to
Right.
go.
So is it going to be in quadrant 4?
Yes,
Okay.
right there, right there. Pi over 4. So our related acute angle is pi over 4. Okay. CAST. So this means cosine of negative pi over 4. See, cosine is positive in quadrant 4. Okay. So this is the exact same thing as cosine of positive pi over 4, because cosine is positive in quadrant 4. And cosine of pi over 4, I think it's 1 over root 2. Sometimes written as root 2 over 2, if you rationalize the denominator.
Right.
Alrighty?
Okay.
So this one. Sketch the graph of this on the domain this. Step 1, if you notice, the phase shift is not in the right form, okay? Do you see that? What's the phase shift here?
Like after you what's it called? Like factor it down, or the phase shift that it's given in the.
Yeah, so we need to factor this down. Yeah, this is not our phase shift.
Okay, yeah.
To see the phase shift, you need to pluck out a 3 there.
Yeah.
-2 cosine. If you pluck out a 3, what are you left with in this bracket?
3x plus.
Oh, there's no longer a 3 there, right? We plucked it out.
Oh yeah, that's what I meant. Like 3 and then bracket x.
Yeah.
Would it be pi over 4?
Right.
Or
Yeah.
okay, yeah.
Okay, there we go. So our phase shift, which is the d value, is minus pi over 4. And the notation I use is this one, okay? Y equals a sine cos, doesn't really matter, cos k x minus d plus c, the one from the book. So comparing this equation to this equation, I got these 4 values, okay? And it tells us a few things. We know the midpoint is a 3. You see the c value? That's the axis of curve. 1, 2, 3. So this is our midpoint, alrighty?
Okay.
What's our maximum value?
3.
Nope, 3 is the midpoint.
Oh, 6.
Nope.
For the maximum?
Yeah, so the maximum is 3 and 2 units up, okay? The amplitude.
Oh, right. Okay.
It's at 5. Our maximum
Yeah,
is at
yeah.
5. Where's our minimum?
That would be at 1.
That'd be at 1, exactly. Okay?
Okay.
So what is our period? Period is equals to, yeah?
Well, we're working with cosine in the parent function is usually 2 pi.
Right.
So it would be 2 pi over 3.
Yeah, it would be 2 pi over 3.
Okay.
Okay. Here's another way of doing this if you don't want to use the tables from yesterday. But this one doesn't always work, but I think it should work here. So
Mhm.
once you find the period, what you want to do is you want to find your scale factor, okay? Like how much do you want to go up by each time?
Okay.
And this is the best thing to do is to do 1/4 of period. Or 1/4 times the period. Or divide the period by 4. So that gives me
Okay.
2 pi over 12. That is pi over 6.
Okay.
Alrighty. So we're
Yeah.
going to go up and down by pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Negative pi over 6, just in case. Cool.
Yeah.
Maybe I can simplify this actually. So the next one was 2 pi over 6, which is pi over 3. The next one was 3 pi over 6, which is pi over 2. The next one was 4 pi over 6, which is 2 pi over 3. 5 pi over 6, we can't reduce it, and 6 pi over 6 is just a pi.
Yeah.
Okay, do you understand this?
Yeah.
This is 2 pi over 6, 3 pi over 6. I just reduced it. Alrighty, now where is our very first point? This is a cosine function, right? And it is a negative cosine function. Does a negative cosine function start at the maximum or the minimum?
The minimum.
The minimum, right? So that's negative pi over 3. So our phase shift was what? Negative pi over 3? Yeah, or sorry, negative pi over 4, which is 45. Yeah.
Yeah.
45 is dead center between 60 and 30. Okay.
Okay.
So that means right here in the middle, we will be at 1.
Okay.
Okay. And from here, do we go up or do we go down?
Down.
No. Minimum from minimum, you would want to go up,
Oh,
right?
right. Yeah.
Okay. And now look at this. Why did we do this entire thing? That means for every box you go across, okay,
Mm-hmm.
the next box here would be here. From the minimum, go to the axis of curve. From the axis of curve, go up to the maximum. From the maximum, come down to the axis of curve. Basically, any sine or cosine is split up into 4 different parts. You see this, 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 and then this again. Again, this point is given in the question, okay?
Mm-hmm.
Negative pi over 4, we're at a minimum, right? Because that's where the graph starts, negative cosine function. That means the next point is going to be 1 unit apart at the equation of axis. The next one is 1 unit apart at a maximum. The next one is 1 unit apart at the equation of axis, and then you just keep going.
Mm-hmm.
The next one will be down here, you see? The next one will be, so 1 unit apart here. The next one will be 1 unit apart here, and then you just keep joining the dots and you're good. So the graph will look something like this. Cool?
Mm-hmm.
And if you want to be super technical, it says up to pi, 0 to pi. So I'm just going to erase this. So I just finished at pi right there. Now I'm also going to erase this portion to the left because it says from 0 to pi. So I'm just going to give them from there to there. Okay.
Mm-hmm.
Does that make sense?
Yeah.
You could also
Well,
use the way we did yesterday with the tables, but that one is a little bit tedious. And if you're not used to it, then that one ends up becoming more difficult.
yeah, the graphing I like have down pretty well.
Okay. That's good. That's good. This one's a difficult one. It's not really difficult, but so what's going on here? The dog completes 252 revolutions in 2 minutes and 28 seconds. What is the angular velocity? So the angular velocity W is given by theta in radians divided by time in seconds.
Okay. We've never done anything like this before.
All right, it's not hard. We just do
Okay.
this. So if he does, in 1 revolution, what's the angle they travel? 2 pi, yeah? Every revolution they travel 360 degrees or 2 pi. That means in 252 revolutions, what's the angle they travel? It's going to be 252 times 2 pi.
Okay, let me see the we divide that by 120 plus 28.
Yeah, we divide that by the time. The time is in seconds, right? So in 2 minutes, there's 120 seconds.
Yeah, so
And
it's 41.2.
All right. So there we go. That's our angular velocity in radians per second.
That's it?
That's it, yeah.
Okay, hold on. Okay.
It's just W equals theta over T, okay? There's a part B as well, though. That could be a little bit more difficult. Let's see. Same question, like a follow-up question to that. It says if the tip, the dog's tail, travels this distance in this, find the radius of the dog's rotation. That one is a little bit tricky, I think. How do we do this? So let's talk about this, okay? So if a dog does a full rotation, yeah? What is the distance traveled? The distance is given by the circumference, right? So in 1 rotation, the dog travels 2 pi r. Yeah? So that means 1805, how many rotations did he do? He did 1805 over 2 pi r, yeah? That's not gonna be a nice number though. Completes, oh, we have the angular, oh yeah, we had that, right? We had W equals 41.2 radians per second, yeah? And we know that the time is 20 seconds, and we know the distance is 1805, yeah?
Yeah.
What are they asking us? They're asking us for R. R equals what? So you're looking for a unit of time, or sorry, not time, of length, okay? Let's check this out. We have the angular velocity. If we multiply this by the time, yeah, the seconds, they cancel out, and this will give us the angle traveled in 20 seconds. 41.2 times 20. So the angle traveled in 20 seconds is 824 radians. Right? So 824 radians. How many rotations is that? So just divide that by 2 pi.
Yeah.
So 824 divided by 2 pi. Make sure to put the 2 pi in a bracket.
Okay.
So that is 131.14 rotations.
Yeah, I got that.
So we know in 1 rotation, we travel how much? 2 pi r?
Yeah.
Okay. And we know in 131.14 rotations, we traveled 1805, yeah?
Yeah.
So that means this is equals to this, you see?
Okay.
And then you just solve for r. 2 pi r equals 1805. So r is 1805 divided by 2 pi, right? Divided by 2 pi. So the answer is pretty big. 280, so did I do this right? 1805 divided by, oh, no, I forgot one step. Here, look at this. So one rotation, yeah? One rotation would be 1805 over 131.14.
Okay.
That is 1805 divided by 131.14, and that is 13.76.
Okay.
Okay, so one rotation is 13.76. That means 2 pi r is 13.76. And divide both sides by 2 pi, and you'll have the answer. 13.76 divided by 2 pi. The answer is 2.19 centimeters. Okay, this one was a little bit difficult.
Yeah.
Hopefully it doesn't come, but if it does come, just remember W is theta over T, okay? And you just need to play around with the units for anything more difficult that they ask you. Okay,
Okay.
this one we can do. All right, we know a bunch of things here. Let's make a rough sketch. What is the minimum value here? That's the first question.
1.5.
Right. What is the maximum value?
9.
No. So the radius is 9, right?
Okay.
So he boarded it. So the Ferris wheel looks like this, you see?
Okay. Yeah.
So from 1.5, the maximum value is gonna be 19.5 because the diameter of the Ferris wheel, right, is 18. So there's 9 units here, 9 units here. Total is 18. So just add 18 to 1.5 to find the maximum value.
Wait, but how do we know that the radius is 18?
No, the radius
Oh,
is
the
9.
diameter. Okay, okay,
The
yeah.
radius is 9, the diameter is 18,
Yeah.
right? So from 1.5 to 9 and then 9 up more 9. So the maximum value is 19.5. Okay. That makes sense? So that means that, again, we need to first come up with this. And where does he board? He boarded at the bottom. So that means it's a minimum cosine. We need to use a negative cosine function here. Okay. Ideally, that's what we would do. Let's find this one by one. The C value is the midpoint between these two. That will be 10.5, yeah?
Yeah.
So C is 10.5. The amplitude is the distance from the midpoint up or down.
Up.
Up, right? So, well, it doesn't matter up or down, but it's both ways. What's the distance from the midpoint, either up or down? How far apart is 19.5 from 10.5?
9.
9. So your amplitude is 9, okay?
Yeah.
Cosine. Now K value, K is 2 pi over the period. So it's going to be 2 pi and the period is 16, you see?
Yeah.
So that's pi over 8. Yeah?
Yeah.
And if the guy is boarding at the bottom, which is at the minimum value, yeah?
Yeah.
He's boarding at the bottom. What's the phase shift? 0.
Yeah, I was just gonna say there is no phase shift.
There's no phase shift. So there we go. That's our equation. H of t, and they wanted t here. All right. And that'll be the final answer to this question. Okay. Y and this. Part B, use your equation to find this guy's height when he's been on the ride for 1 minute and 30 seconds. Very simple question. It's just a plug and chug question.
Um, yeah, you would just plug that into the equation that you have, right?
Yeah, you just plug what into the equation?
1 minute and 30 seconds.
Yeah. Try plugging it in. Do you plug 90 or 1.5?
1.5, right?
Yeah. No. So the time here is in seconds, you see?
Oh, okay,
16
yeah. So
seconds,
90.
90 exactly. So you just plug T as 90 and whatever that gives you.
So we have 9 cos pi over 8 times. I got 748.3.
All right, so that's out of our range. So that's probably not right. Here, you do this. Are you in radians? Maybe you're in degrees?
Yeah, I am.
Okay, you want to do this. 9 cosine, bracket open,
Yeah.
pi times 90 divided by 8 plus 10.5.
Okay, pi times 90. 4.1.
Yeah, that's in our range, right? So that's probably right. 748 is a little bit off. Just a little bit, yeah. That makes sense?
Just a little bit.
So again, remember this, AKDC, okay? Find the equation of the axis of curve, I think your teacher calls it, the midpoint line, yeah? Using that, find the amplitude. You can find the K value using the period, and D is the phase shift, and that depends. D is the last thing you want to do. Okay? This question, yeah, let's do this one. How do we do this?
Not quite sure.
All right, identify which quadrant this ratio must be in. They've given you a restriction, yeah? They're saying it's either, it's between 90 to 270, you know, pi over 2 to 3 pi over 2.
Yeah.
That means our thingamajig is in either quadrant 2 or quadrant 3, okay? Which one is it in though? Cosecant is positive, so which one
Yeah.
must it be?
That
Quadrant 2,
means that, yeah.
okay?
Yeah.
From there, you want to draw a triangle. You know, sine is opposite over hypotenuse, right? That means cosecant
Is
is
hypotenuse over opposite.
right, hypotenuse over opposite, and the value of hypotenuse is 2. The value of opposite is √3. So you can say this is your angle, okay? That's your related acute angle.
So that's going to be pi over 6.
Yes, it is. So our related acute angle is pi over 6. Our theta is the principal angle, okay? What will that be? Yeah, so this is pi over 6, yeah, from here. We want to find out what that is, the big one.
So if pi over 6, so 150.
Yeah, 150 or just pi minus pi over 6, yeah? 5 pi over 6. And there you go, that's the answer. Okay? So again, identify the quadrant, draw a triangle if you have to, and yada yada. What if they didn't give you this restriction? Then what would we do? Maybe it said from 0 to 2 pi. Would our answer change? Instead of being from 90 to 270, what if it was from 0 to 2 pi? Does the answer change?
No.
So if it's from 0 to 2 pi, that means there must be another quadrant where cosecant is positive. That's going to be in quadrant 1. So our answer would include both of these angles.
Okay.
Okay, because you can draw a triangle in quadrant 1 with those ratios, right? And the
you'll
angle
still
would
get
be
the
pi over
same.
6. Yeah.
Okay, yeah.
That makes sense?
Yeah.
All right, I think this one, I'm not going to bother. Just sketch the graph of cotangent of x. Would you be able to do this?
Oh, he's not even going to be asking this on the test.
Okay, all right, perfect. So let's not worry about that.
Can we work more on word problems?
Sure. Let's see if I can find some. There's a bunch of them yesterday, right?
Yeah.
Yeah, there's one here, and then there's also one in this test. All right. So a tower that is 65 meters high makes an obtuse angle with the ground. What does that mean? That means our tower is probably slanted, right?
Mm-hmm.
Because otherwise there's no way it makes an obtuse angle. So that's our tower. How tall is it? It's 65 meters, yeah? This way, not vertical distance.
Mm-hmm.
And then the vertical distance from the top of the tower to the ground is 59, all right? So this distance is 59. What obtuse angle does the tower make with the ground to the nearest hundredth of a radian? I basically want to find x. Let's call this angle x.
Yeah.
It's easier than you think.
So
Yeah.
can't we just like plug in Pythagorean theorem to find like the missing length at the bottom?
Yeah, sure, we could. Does that help us though?
Well, I'm just thinking if we do that, then
Yeah, that's gonna be 27.27 or 27 point, yeah, approximately. Well, we don't need the
okay,
bottom
well,
side.
yeah, we need that angle in
Yeah,
there,
we
like
need the same.
across from 90.
Yes.
Uh, I'm not sure.
Just use SOHCAHTOA. You don't even need the bottom one. So in this triangle,
Okay.
relative to theta, you have the opposite, right?
Mm-hmm.
You have the hypotenuse of that triangle as well. So you see you have O and H, you need to use sine.
Fine, yeah.
So sine theta equals 59 over 65. Theta is going to be sine inverse of this.
Okay, so if we do sine of 59 over 65, 1.1.
Yeah, 1.1. And then what? It says hundredths, so let's do 2 decimal places.
Okay, so 1.4, 1.14, yeah.
Yeah. So now how do we find x?
So the angle is 1.14.
Yeah, the theta is 1.14. We need to find the obtuse angle x.
Okay, so then wouldn't we just take 180 minus 1.14?
You wouldn't get points for it because what's the mistake? The idea is right. It's just a small error in that we're in radians, right? So we can't use 180.
Oh, right. So we would need to use pi.
Pi, exactly. So x is going to be pi minus 1.14. So that's like 3.14 minus 1.14. That's like 3.00.
I got 2.00.
Yeah, you're right. You're right. I'm wrong. So There we go. That's the answer. 2.00
Yeah.
radians.
Okay.
That one was easy. Yeah, it wasn't. It just looked difficult, but it wasn't. Wasn't that bad. There was a question here. This one. So they're asking you to find the distance between A and B. Okay. When the plane is 420 kilometers horizontally from Trig town, so that means you see this distance here from here to here is 420. The pilot notices that the angle of depression to the Sign City airport is 45 degrees. So again, how does an angle of depression work? Angle of depression and angle of elevation, okay? Both from grade 11. It's always from the horizontal. You see, this is the angle of elevation.
Yeah.
This would be the angle of depression from the horizontal. So that means this angle is 45. And then after traveling another 30 kilometers horizontally, so that means the distance from here to here is 30. And the height difference is 4, okay? So the height from here to here is 4. He notices that the angle of depression is 60 degrees. This one's pretty tricky. Maybe, we'll see. How far, exactly how far, that means we just need to write the exact ratios, is the distance from A to B. Yeah, this is how you do this, okay? Can you think of it? What do? We need to make a triangle. That's for sure. We need to make a triangle that looks like this. So if you look at from this position to this position, yeah, the distance traveled is 4 kilometers down, and the distance traveled horizontally is 30 kilometers, yeah? And this is 45. Actually, does that work? We have opposite and adjacent, right? No, that doesn't work. That does not work. Because tan 45 is an isosceles triangle. So they both should have been 4 and 4. So that one doesn't work. Okay, I get it. So you got to look at the big piece, big triangle here. From this position, yeah, all the way there, yeah. We have this all the way down there. That is 45 degrees, right? And we know, what else do you know any sides to this triangle? No, we don't. I'm gonna call this H, the big height here.
Yeah.
Call this H, and I'm gonna call the distance from here to here X, okay?
Okay.
Distance from there to there, I'm gonna call X. Cool. Notice this is 45 degrees, right? 45 degrees means what? It's an isosceles triangle. This side also must be 45.
Yeah.
So that means this side is also an X. Basically, H is X.
Okay.
Okay, that's what we get from the first triangle. Now let's look at the second triangle, okay? The second triangle from the 60-degree mark. Remember the height before was H? We came down 4 units, so what's the new height?
4?
H minus 4 or X minus 4.
Okay.
Because H is X, yeah?
Okay.
And remember, this entire thing from here to here is x. We travel 30 kilometers. Okay.
Mm-hmm.
So what's the distance here?
X minus 30.
Right, x minus 30. There we go. And now we just use tan, right? Tan 60. Yeah. Because we have the opposite and we have the adjacent. So tan of 60 is equals to x minus 4 over x minus 30. That's not a degree. That's just, yeah, the kilometers.
Okay.
Cool.
Yeah.
All right, what's the value of tan 60? And why did I call it 60? Oh, because they are given us in degrees. All right, that's fine. Tan 60, I believe, is root 3.
Yeah.
So root 3 equals x minus 4 over x minus 30. How do you solve this equation for x?
So can't we bring the x minus 30 and multiply it by root 3?
Yes, that's exactly what you do. So you do root 3x minus root 3 30, or 30 root 3. Let me just rewrite it like this. 30 root 3 equals x minus 4.
Why'd you do 30 root 3?
You usually write the number before the root. That's why. This is the same thing. You can write root 330.
No, I know, but I mean, like, because you already put root 3 and then x minus, like, wouldn't it just be root 3 x minus 30?
No, it won't be, because you're multiplying both sides by x minus 30. If you open this bracket, you see you get root 3x
Oh, right.
and then root 3, yeah. So the root 3 applies to both of these terms.
Right. Okay. Yeah.
And now we simply want to group up the x's to the same side. I'm going to move this x to this side, root 3x minus x. I'm going to move this guy to this side. I got 30 root 3 minus 4. Okay.
Okay.
Why did I do that? Because we're trying to solve for x, right? We're trying to solve for x, so you need the x's on the same side. Again, it says the exact value, so we can't plug anything in the calculator. What do we do next? Trying to find the x, basically.
Yeah. Then you'll just isolate for x?
Yes. But how do we do that? Where do you have x's on the same side?
So first we could simplify it, right?
No, there's only one thing you could do here. I mean, if it didn't ask you for the exact value, you could plug this in a calculator, root 3, whatever root 3x is, and then you want to subtract 1x from this. But here, there's only one thing you can do, and that is factor out an x.
Okay.
That's going to give you root 3 minus 1. Okay, like that. And then you want to divide both sides by this bracket, and you'll have x. So therefore, x is equals to 30 root 3 minus 4 over root 3 minus 1.
Okay.
And they want the total distance. We know the total distance is 420 plus x. Therefore, you just add 420 to this, and that'll be the final answer.
Okay.
Okay, this is the total distance. This is AB, basically, the distance from A to B. X plus 420. Okay? This one was a little bit tricky. I mean, if you do get something like this, just draw triangles, and then from the first triangle, you're going to be subbing things into this next triangle. Okay, here from the first triangle, we deduce that h is x, and then we sub that in the second triangle to solve for x. Okay?
Okay.
We can try doing this. So she draws 2 points. In which quadrant is this point?
Quadrant 3.
So x is positive, y is negative. It should be quadrant 4.
Oh, okay.
Okay. So I'm just gonna say this point right there. That's 7 comma, -7√3, okay? Maybe you can even draw like a triangle out of it.
Okay.
That means the horizontal distance is 7 and the vertical distance is 7√3.
Mm-hmm.
Okay, there, and then where's this one?
Third quadrant.
Right, so that's in the third quadrant. Yeah, it won't be at the same position, yeah?
Mm-hmm.
So let's say that is, and again, we're gonna make a triangle out of it. The horizontal distance is 6, the vertical distance is 6√3. Alrighty?
Mm-hmm.
I'll call that, yeah, I can call that an X. So what do they actually want? She then draws line segments from the origin to each point. Okay, so this one, and this one. Using radian measure, find the exact value for the cosine of the smaller angle between the two lines. I think they want this one. The angle in the middle.
Okay.
Angle between the, yeah, because there's the smaller angle and the bigger angle is this reflex angle, right? Like now. So they don't want the bigger one, they want the small one, so they want the angle right in the middle. All right.
Okay.
Any ideas on how to do this?
Well, first, could we find the angles for like each of the,
Yeah, we can, right? And there both of them, we don't have the hypotenuse, so we'd be using tan. So
Mhm.
tan x equals 6√3 over 6. So that means tan x is √3, yeah?
Mhm.
That means x is what?
Um,
Pi over 3, yeah, 60.
okay, yeah.
On the other side, we have tan x equals, same thing, right? The same thing, 7, yeah, this cancels out. So on the other side, theta is also pi over 3 or 60, because we're left with √3.
Mhm.
Now what do? We have theta, we have x.
Um,
How do we find this middle angle? You just do pi minus both of them, yeah?
okay.
If this is 60, if this is 60, we know the entire thing is 180, right? So the middle
Mhm.
angle must be 60. Or you can do pi minus, because we know this entire thing is pi degrees, right? Pi radians. Entire thing, pi radians. So pi minus x is pi over 3. And theta is also pi over 3. So there you go, that's the answer. Pi minus pi over 3 over pi minus 3. So that just gives you pi over 3 as well.
Okay.
And that's the final answer. So the angle in the middle must be 60 as well.
Okay.
That makes sense?
Yeah.
That one wasn't that bad. You just have to correctly identify in which quadrants the points are.
Mhm.
Cool?
Yeah.
Alrighty, let's call it a day there then.
All right. Thank you. I'll email you when I want my next session.
Sounds good.
All right. Bye.
Bye.